All right, welcome to Unit 3, Day 2 notes. This is while I'm gone, and hopefully if anybody is absent, you'll be able to watch this. You can grab this off our Google Classroom. But we're going to start with doing some geometric proofs today. So we did algebraic our first day. We're going to move into some geometric. I also want to remind some definitions that we've already seen, but I want to make sure that we have these down. And the first one is the midpoint theorem, and that states basically that if M is the midpoint of line segment AB, then line segment AM is congruent to line segment MB. And that should make sense that if AM and MB, those should be equal, and that they are going to be, because M is the midpoint of AB. We can also use it as the definition of, and I'm going to abbreviate definition of midpoint. And I would use that if I want to use the equals and not the congruent sign, and that is basically if M is the midpoint of AB, so I'm going to write if M is the endpoint of AB, then AM is equal to MB. I can use it the exact same as the midpoint theorem, but you can use equals by the definition of midpoint. They basically mean the same thing. One is in congruence, which is the midpoint theorem. Definition of midpoint is with equals. And the second one we have definitely seen before. If A, B, and C are collinear, then point B is between A and C if and only if AB plus BC equals AC. We have seen the segment addition postulate before. All right, moving on. Our first foray into a geometric proof. Okay, this is our first attempt at it. So I want to go ahead and build our proof, and that is I want to go ahead and say the statements and my reasons. Okay, now let's take a look at what it's asking us. It says prove that if line segment AB is congruent to line segment CD, then line segment AC is congruent to BD. Okay, I've also given it to you in the given and prove part where it says given line segment AB is congruent to line segment CD, and I want to prove line segment AC is congruent to BD. All right, so the first thing we talked about, the first thing we want to write is our given. So we're going to write the given. Line segment AB is congruent to line segment CD. And why? Because it's given to us. It is given to us. And what does that mean? AB is congruent to CD. Well, this part right here is congruent to this. Well, I look at that and I want to prove that AC, this part right here, is congruent to BD, this part. How am I going to do that? Well, I think I'm going to use segment addition. All right, so first thing I want to do is I'm going to move out of congruence and into equals. So I'm going to take this and I'm going to say that AB is equal to CD, and that is by definition of congruence. And then I'm going to look at it and I want to say, well, what do I know? Well, my brain, I know that if AB plus BC, that's going to equal to AC. Well, AC is what I want to try to prove. I want to get to AC. I also know that if BC is added to CD, then it gives me BD. Well, look at that. BD. I already know that AB and CD are equal, and those are parts of that. BC is itself. So let's go ahead and do that. AB plus BC equals AC, and BC plus CD equals BD. And once again, the reason for that is segment addition postulate. Notice my abbreviation for segment, ADD for addition, and POST for postulate. My fourth one, well, look at this. I've got AC and BD already here. I already know that AB and CD are congruent or equal, and I know BC is itself. By transitive property, I can say that AC is equal to BD, because if I have one thing equal to one thing, and I add something else and it's equal to it, then the first two, or the first and third item, are equal. So this is going to be transitive property. And now I'm in equals, and I want congruence, so I'm going to move back down into congruence. So this says line segment AC is congruent to line segment PD. Why? Definition of congruence. Now, you're going to have to pause this and catch back up to me and looking at it. But remember, I said the other day that the transitive property is a big one. It is. It's one that we're going to use a ton. So go ahead and pause now. Make sure you have it down before moving on. All right, here we go. The next one, given DA is equal to BC. DA is equal to BC. I want to prove that DB is equal to AC. I want to prove that DB, this part right here, is equal to AC, or this part right there. Okay? Well, I've kind of helped us out here a little bit. I've already given the statements down. We just got to figure out why those are done. So DA equals BC. Well, of course, that's the given. It's right up here and listed for me as the given. The next step, DA plus AB is equal to BC plus AB. Well, what have I done? Well, I've added AB to both sides. So this is going to be the addition property right there, because all I've done is add AB to both sides. Now I look at it and I go DA plus AB equals DB. Okay, well that makes sense. That's segment addition. And then AB plus BC equals AC. Well, I know that AB plus BC is equal to AC by segment addition postulate. So the segment addition postulate. Well, I wanted to prove DB is equal to AC. Well, once again, look at it. I have DA equal to BC, so I know those two are equal. And AB is itself, so DB plus, or DB equals AC. How is that? It is by, you guessed it, transitive. A transitive property. Once again, if you need to pause, go ahead and do so, and then before moving on. Alright. Couple more things. Here we go. Learning some vocab. Vocab. It says types of lines. We want to identify and use properties of parallel lines with transversals, corresponding angles, and alternate interior and exterior angles. Alright, so looking at the definition of intersecting lines are two lines that, one, intersect or cross, use it interchangeably, and are coplanar, which means they are in the same plane. We learned that in the very first unit. The second definition is definition of perpendicular lines. Two lines that, one, intersect or cross to form a right angle. A lot of times you're going to see this little square in there that tells me it's a right angle. The second part of two perpendicular lines is they are coplanar or in the same plane. The third definition of parallel lines. Parallel lines are two lines that are never going to cross or intersect, and they are coplanar, meaning they are in the same plane. And the fourth definition that we want to look at is the definition of skewed lines. And that is, there are two lines that are never going to intersect, they do not cross, or are not coplanar. They are not in the same plane. They are not in the same plane, so they're different than parallel lines. Parallel lines are always going to be in the same plane. Skewed lines are never going to be in the same plane. Okay? We're going to use these four definitions, these four ideas, these four types of lines for using some information and answering some questions. So here we go. Think of each segment in the diagram as part of a line. Which of the lines appear to fit the description? So the first one, it says parallel to line segment AB and contains D. Well, where is line segment AB? Well, line segment AD is this one right here, and it's in red on your piece of paper, on your set of notes, so I'm going to keep it in red. It's right there. Now, I want to be parallel to that line segment, and I want to go through the point D. Well, this one to me is pretty easy. If I want to be parallel to it and I want to go through D, I'm going to go right through there. So this becomes CD, or line segment CD, is going to be parallel to line segment AB going through the point D. Perpendicular to AB, or line segment AB, it contains D. Perpendicular. Well, remember, perpendicular crosses, and it crosses where it forms a 90-degree angle. Well, to me, going through point D and perpendicular to AB is going to be this line right there. So it would be through line segment AD to be perpendicular to AB, or line segment AB going through the point D. And the next one, skew to line segment AB and contains D. There's going to be three of them. Well, I'm going through the point D and I want to be skewed to AB. Remember, skew, not in the same plane. It's not in the same plane. So I know that it can't cross and is never going to be in the same plane. Well, I see three of them. I see ED, I see GD, and which other one do you see? Hopefully you said DH. And those would be my three that are going to be skew to line segment AB going through the point D. So this is going to be line segment ED, line segment GD, and line segment DH. All of those. Those are the three. And then name the plane or planes that contain D and appear to be parallel to plane A, B, E. Well, to me, ABE is going to be this plane right in there. So I want one that's going to be parallel to it. So it has to be over here going the same direction. And I want it to contain D. So for me, that's going to be plane. What is that? DCG. Alright, DCG. Once again, pause if I'm going too fast for you. You can slow it down, take a look at the diagram, all that. Alright, moving on. I want you to go ahead and do these. I want you to pause now, right after I'm done speaking, and try these on your own. After you try it, see if you come up with the same answer as I do. Alright, pause now. Alright, welcome back. Hopefully you get what I got. First one should be UV. Line segment UV, parallel to TW and contains V. perpendicular to line TW, or line segment TW and contains V. That would be VW. VW. Skew to TW and contains V. Skew. That would be VS. Line segment VS. And name the planes that contain V and appear to be parallel to line, to plane TPQ. Well, to me, that's going to be plane, and you want TPQ and to be parallel. That is V, R, and S. V, R, and S. Hopefully, you got what I got. Moving on, last page. Transversal. Big vocabulary word for us. All right, a transversal is a line that intersects two or more coplanar lines at different points. You have the diagram where I have line M and I have line X, and cutting them is line T. Line T is considered to be the transversal of that. Well, notice how many sides it creates. I've got 1 here, 2, 3, 4, 5, 6, 7, 8. It created 8 angles for me. This transversal cutting 2 lines created 8 angles. This is going to be very important for us as we move along in this unit. Okay, so this is a transversal, a line that cuts or intersects 2 or more coplanar lines at different points. All right, so let's see what happens. Let's see what the relationship between these angles are that transversal creates. The first one, the definition is of alternate interior angles. So the definition of alternate interior angles is 2 angles that between the 2 lines and opposite sides of the transversal. 2 angles that are between the 2 lines and are on opposite sides of the transversal. Opposite sides of the transversal. So opposite sides, so they got to be one on this side, one on the other, and they have to be between the 2 lines. So this line and this line. Well, when I look at this, my alternate interior angles are going to be 3 and 4 and 1 and 2. And let me kind of highlight that for you. So angle 3 and angle 4 are alternate interior with each other. And angle 1 and angle 2 are alternate interior angles with one another. Right? This is a big one. We're going to use this a lot. So definition of alternate interior angles. Okay? So this is called alternate interior angles. The second one, same side interior angles. Same side interior angles. Okay? So we're looking for the same side interior angles. They are between the 2 lines and on the same side of the transversal, meaning they're on the exact same side of this line, the transversal line, but they have to be between the 2 lines. So in this case, this one is going to be 1 and 4, 3 and 2. 1 and 4, 3 and 2. Those are going to be our same side interior angles. Okay? All right, moving on. Definition of corresponding angles. The definition of corresponding angles. Corresponding, another big one that we want to make sure we get into our heads. 2 angles that are on the same side of the transversal in same position for both lines. Same position for both lines. Corresponding, which means on the same side of the transversal, so it's either going to be all on the right or all on the left, and are in the same position for both lines, meaning they're on the top or on the bottom. In this regard, corresponding in this case is going to be angles 6 and 2, 3 and 8. I'm going to have 5 and 4, 1 and 7. Those are my corresponding angles. My corresponding angles, 6 and 2, 3 and 8, 1 and 7, 5 and 4. Because here's the reason. Let's look at 6 and 2. 6 is on top of this line. 2 is on top of this line. It's on the same side of the transversal, which means it's on the right-hand side of the transversal, but it's on the top position. Conversely, 3 and 8, 3 is on the bottom of this line, while 8's on the bottom as well. Okay? So this is your corresponding angles. The last definition was alternate exterior angles. Alternate exterior. I really like this one. You're going to use it quite a bit. And this is outside of the two lines, and they are opposite sides of the transversal, meaning they're not adjacent. They're not adjacent. So alternate exterior, I'm going to have 5 and 8, 6 and 7. 6 and 7, 5 and 8 are my alternate exterior. If I circle them, outside, outside, opposite sides. 5 and 8, 5 and 8, outside, outside, and they are on the opposite sides of the transversal. All right. Little practice with it. Looking at these two lines cut by the transversal, let's find out the answers. The first one, corresponding. Corresponding. Well, my corresponding, what was corresponding again? Correspondings are on the same side of the transversal, in same position for both. So I look at this, my correspondings. They're going to be like 2 and 6, 4 and 8, 1 and 5, 3 and 7. So 2 and 6, 4 and 8, 1 and 5, 3 and 7. Those are my corresponding. My alternate interior. Alternate interior. For me, I look at these, they're on the opposite sides of the transversal, but they're inside the two lines. So alternate interior, it's going to be 4 and 5, 3 and 6, 3 and 6. Alternate exterior, alternate exterior. That is going to be your 1 and 8, 2 and 7, 2 and 7. And last but not least, same side interior. Same side interior. 4 and 6, 3 and 5. Make sure you use your definitions. Look at the examples when doing this. Hopefully you have a great day on Monday. I'll see you in class on Wednesday when I get back. Have a great day.